All right, I remembered to record today, and I'm going to put the slide first, so somebody will always remember to tell me to hit record. All right. So what you should have done up to this point, and if you haven't, that's okay. I think the online's got you to September 10th because I'm a little ahead from what the book wanted. So I had chapter 1 going from last week and this week. Chapter 1 didn't need that long. This is me being a new book and not knowing exactly how long certain things are going to take, which is fine. So chapter 1 is done. You should be able to do that assignment in Hawks. We're going to do chapter 2 basically tonight. I'm going to cover a little bit more of it on Thursday, and then we're going to move into chapter 3, which chapter 2 is actually next week's assignment. So we're basically like a week ahead now. But that also means that chapter 3, I'm going to be able to expand out a little bit more. And chapter 4, I'll be able to expand out a little bit more. So, and those are the first 2 chapters that we're really going to be getting into actually doing math, doing some calculations, and understand, like doing those type of things with data. So I think expanding those out a little bit will be a good thing. So if you've gone into Hawks, and it seems like the majority of you have signed up for your accounts, which is great. Don't forget, if you use the temporary password or temporary login, that only goes, it's only 14 days. So it's like the 17th or 19th around there that code will run out. So you have like another week or so to be able to get your permanent account for that. If you haven't done that already, please make sure you do that, because I think next week I'm going to have to fill out if you're non-participating or not. And if I don't see your name in that list, I'm going to put down that you're not participating even if you've shown up for class. So, and they will remove you from the class, and there's no like option to get put back into the class if that happens. So please, please, please make sure you sign up for Hawks, even if you're going to use the temporary password for the next couple weeks. All right. Any questions with that? Somebody did ask, you do not need the actual hardcover book for this class. Everything that I'm going to cover that is that's on the quizzes and stuff in the actual class, I'm covering in class. So you don't need the hardcover book. You get an ebook with the code, so you can use that there. But other than that, you don't need anything outside of that. And I think this said the code was like $89 through Hawks. You don't even need to go to the bookstore to do it. You can do it right online. Okay. Any questions with any of that? Okay. On to the fun stuff. Oh. The stuff that we have to learn. Not always the funnest stuff in the world, but the stuff that we have to do. All right, so we're going to start looking at a little bit more terminology really today, and more definitions, unfortunately. But it's how we start to categorize data and how we start to categorize how we do things. Because depending on how we're working with it, and depending on what types of data it is, really decides what we can do with that data. All right, there's lots of data collection that we can do. Some things are more useful than others in terms of calculations. However, before we start looking at data, we have to figure out how we're going to collect data. There is 2 main ways to collect data: observational and a controlled experiment. A survey would be what? What do you think a survey would be? Why? Okay. So a survey is actually observational because you're not really doing anything. So you're just collecting the data, which you could do just by observing somebody. So when you're observing something, you're just collecting information, and then you can do stuff with it. A controlled experiment is where you actually have like you have subjects, are doing something over time with them. You could have a control group, those type of things that are built in. So this way you can see what's happening in terms of that respect. That's more of a controlled experiment. Most simple things are observational data. The downside is observational data is not always the most accurate information. So controlled experiments are the ones that are used to do more of your scientific research and stuff like that. Any kind of drug research is always going to be a controlled experiment, for example. Okay. When you're looking at controlled experiments, there are some restrictions on what you can do. It's a lot of work to actually to do an experiment on children, for example. There's a lot of paperwork and forms and everything else you have to fill out. Even if I wanted to, like when I was in high school, if I wanted to collect data from my classes, like actually have the students do something or do something with 2 different classes and things like that, everything would have to be signed off by their parents and forms and everything else filled out before anything like that can be done in a class. College level, I don't have to. I can just tell you I'm doing it and you can agree. We don't have to fill any of those things out. If it's in terms of that it could cause harm, there's, again, a lot more of ethical concerns, stuff like that has to go into it. So a lot of those, the drug researchers and stuff like that, they will take volunteers into the program. Now, when you take people that are volunteering for things, you don't necessarily have that randomized sample. That would be the greatest thing in the world to use. So you have to take what you got. And that can start to cause some conclusions that aren't always completely and utterly accurate. So you do have to think about that when you're doing some of your controlled experiments. The great one that came out, well, that's recently with the COVID data and everything else, is at the very beginning, when they started coming up with the vaccines and they wanted to do trials, they had to take volunteers to take the trial drugs. They had control groups. They had a control group and they had the actual people that were getting the vaccine, so they were able to do those type of things. However, they were looking at how the vaccine worked against the general population that didn't take it. Because what would happen if you were going to volunteer to take this drug? What type of people would volunteer to take that drug?
People who are okay with vaccinations.
People are okay with vaccinations. Okay. Now, yep. Yep. Sometimes money. I actually don't know if they were paying for this one. But a lot of them do. A lot of the medical research and stuff does. All right. What else? Actually, they had a variety. Some older people because they wanted the vaccine, so they would be okay with the vaccine. Now, thinking back to what happened a few years ago, the people that were more likely to take the vaccine were also more likely to do what other things? They were not included in it, actually. They were not included in the study for an entirely different reason, because they were exposed to a lot of other things. Yes. They were more likely to wear masks. They were more likely to social distance. They were more likely to avoid large crowds. So, right. So they were already less likely to get COVID. So you had a group of people who are already less likely to get it, and then they were testing the vaccine on this population of people that were less likely to get that weren't exposing themselves to it. So it showed a very high success rate. And when they rolled it out to the general population, it showed a lot lower success rate because a lot more people that were taking it were doing all those things. So one of the things that this book actually calls, hold on, let me get the exact word because it was hilarious, the word they used. It was called, hold on a second. I can't remember, and I didn't copy it down. Confounding variables. It's basically extra variables that aren't accounted during it that can cause the results to become skewed. So those are variables that they didn't necessarily take into account when they were doing their study. Okay, and there's a lot of things like that. Like you can't necessarily restrict everything, especially when you're dealing with people. When you're dealing with like food and stuff like that, or inanimate objects, you can restrict a lot more stuff. But people, it's a lot harder to do that type of stuff with. So there's going to be extra variables that you just can't account for, and you have to put those into your research studies so that other people understand that this could skew that data. Okay, that makes sense? All right. We have two types of variables. You have your response variable. Your response variable is the measure of, that's the one you're actually measuring in the actual study. And then you have your explanatory variable. These are the reasons why that response variable was happening. So the response is what you're looking for, and then the variables of why that could happen is your explanatory variables. Yes.
What do you mean the outcome of interest?
So let's say I was studying impact of TV watching on grades in class. Okay. My measure of outcome of interest is I have two. The number of hours of TV you watch and your grade. Those are the two response variables that I'm going to be looking for. Okay. So, and then the explanatory variable is the connections between those two. Okay. So that would be what I would be looking for. All right. So we suppose we have a new species of tomato. This actually is true, by the way. That has been genetically engineered to increase yields. Pretty much all the food you eat has been some kind of engineered to increase yields. This is why we can produce so much more corn today than we could 100 years ago. It's not because we have better farming methods, it's because we have better science that allowed us to do that. And it doesn't impact the ground as much, so they can keep planting in the same area. So if you've ever planted a garden and plant vegetables, if you don't rotate them, your vegetables will stop growing because it pulls the nutrients out of the ground, and other vegetables will replenish those nutrients for other vegetables. So if you don't rotate your things in your garden, nothing will grow after a few years. Unless you put chemicals and other stuff in there to help them grow, which is what a lot of people use, like the Miracle-Gro and stuff like that. So, how can we measure whether the new species produces higher yields? So how would you set up this study? Okay. So what are the things that you're going to have to control for? Anybody garden? Tomatoes grow like crazy once you start getting them to grow. My mother has a garden, and like she's constantly giving me tomatoes because they're taking over her yard.
To grow 1 year, every other year, every single plant is
Oh, jeez. I do not have a green thumb. Everything dies in my yard, except for grapevines, which took over my entire yard. All right. So, what are some of the things that we have to control for? Yeah.
Growing space. Water.
Okay. So, space, water, sunlight. So, those are things that across our entire field are going to have to be constant, right? Between our control group and our experimental group. All right. What's the response variable in this case? The yield, right? That's just shout it out. You don't have to raise your hand. It's just, if you think about it, just yell. Worst thing that's going to happen is if somebody keeps yelling out the answer, I'm just going to tell them to be quiet for a minute. So I've done it. It happens. But yeah, just yell at the answer. I taught in high school way too long that the kids would just yell at the answers, and it just took forever to try to sit there. No, I'm going to call on people. It just didn't work. So my response variable is the yields. That's the information I'm going to collect. What is my explanatory variable? So what's the variable that's causing the yield to change? Yes.
The modifications.
Yeah, the genetic engineering, right? That's going to be what's causing that change. Is there any other variables that we are not controlling for? Or if we control for the other things, everything else is controlled for the, huh? Well, if we do a plot in one spot, the weather should be constant. Like, I'm not going to plant tomatoes in Connecticut and California and try to compare them, because yes, the weather would be a major issue there. And actually, if we were looking at doing weather and those type of things, like the climate as an issue, we might want to do that, right? If that was the response variable that I was looking for. In this case, we're looking for just the genetic engineering. We want to see how that impacts it. Okay. So as long as we make the plot so this way, the water's the same, the sunlight's the same, the temperature's the same, the soil's the same, those type of things. They're all fed the same nutrients or whatever else, unless that's the piece that I'm looking at. Like if it's just the seeds that are genetically engineered, we'll be able to tell in that case. So response variable is yield. Explanatory variable is my genetic engineering. Does that make sense? Okay. So I don't think I did. I got this one in there. Nope, I did not. One more example because I like this one. Does an SAT preparation course improve your performance on the SATs?
The screen hasn't changed.
It's not up there. I'm going to put it up there in a second. I didn't put it in there. Thank you. It was one of those things like I was debating on putting it in there, and then I just decided, I'm like, this is a good question. I'm going to use this one. Does the SAT preparation course improve performance on the SAT? So, what's my response variable for this one? Okay, so my SAT scores. And what's the explanatory variable?
Preparation.
Okay, so the preparation course. Good. How would I set up this study? Yes.
You have a group, you gotta have 2 groups of people. Yeah. She said.
Well, I missed. There was noise. I missed. Actually, I heard 2 groups of people, and then he said, "That's what you said." I didn't hear what you said.
Oh yeah, I just said 2 groups of people. One who go through SAT preparation and one who don't, and you'd see the.
Okay,
score
so here's the question. So if I take this side of the group, this classroom, and I send you through the SAT prep class, and I take this side of the classroom and I send them not through the SAT prep class, and I take your SAT scores, right? And I look at it, is the only difference between these 2 groups of people the SAT prep class? No. Yes.
It would be a lot better if you took the same person do the SAT test without courses first and then retest them after.
Okay.
Then they would have the experience of taking the first test as well, so they would know kind of what to expect.
Yes. So see how this is not as simple as it sounds sometimes, right? Those are really the only 2 ways we can do it, correct? Two groups of people. However, if we use 2 different groups of people, there's a lot of variation in those groups of people. There could be economic, social, there could be literally just ability level. Like there's no way to set that for both groups of people. Now, we could, like you said, take the same group of people, have them take the test, have them go through the prep class, and then take the test again. What would be the, as you said, the big thing there would be they have the experience of taking the test already, right?
That's the point.
Right, but then is their increase in score due to them taking the test again, or is it because of the prep class? The average score of a person taking the SATs goes up by 100 points just by taking it a second time, from the first time to the second time. That is how much that experience of taking the test helps, because you understand the situation. You're not as anxious going in there and sitting there for 3-4 hours. There's a lot of variables and stuff that go into taking the test that when you go through it the second time, you're a lot more at ease, you're a lot more comfortable, you understand how to answer questions and stuff like that. They've changed the SATs a ton since I took it. But I've administered it for years through high school. So that can make a difference. However, we have that data. We have the data for all these people that have taken the test multiple times, that we can use that information to eliminate that possibility. So if this group of people that have taken it, gone through the class, and taken it a second time, their score improves by 200 points or 250 points, we can then confidently say that is because of the prep class and not just taking it the second time. Because they already have that data to be able to eliminate. They can say, okay, this group has done significantly better than an average person going through and taking the test the second time. So, but these are the types of things that they have to look at. Okay. And these are also the types of things you never see in a meme that show you a percentage or a data point or a statement. It's like, this is all the stuff that goes into these type of studies. Okay. All right. There's a few different ways you can do your studies. The one that most people have heard of is a placebo. Normally in drug tests, they give you a sugar pill. Why do they have to give you something? Yes. Yes.
Anxiety?
Well, if they don't give you anything, like if they're putting you in a study and they don't give you anything, you know you're not getting the drug. So it kind of ruins that piece of the study because there is a huge psychological effect in terms of treatments. If you have when you have a kid, you can have a medicine bottle and just have a bottle of juice and say, don't worry, I'm just going to give you this medicine and give them juice. They'll feel better. Maybe not always, depending on what's wrong with them, but they will feel a little better than they were before because it's psychological. So they need to eliminate that aspect of it. So by giving them that sugar pill, they don't know if they're getting the pill or not. They don't know if they're getting the drug or not. So they're going to have that psychological effect just like the actual real group's going to have that psychological effect in addition to hopefully the drug helping them. Then, just like we did with the SAT group, we can eliminate out that psychological effect. Okay? By not giving them the placebo, we don't know that psychological effect piece. That's why they do that. The most common study in the medical field are called double-blind studies. In a double-blind study, nobody knows who's getting what. So nobody who's involved in the study knows who's getting what. So somebody outside the study has assigned the groups and marked them, and they know the coding in that way, but nobody actually that's administering the thing would know that. So all the bottles would have numbers on them to give out to people. Even the nurses would not know what's in those bottles. Okay? So this is to prevent any other inside possible biases that would form. Okay? Especially considering some of these studies are done on people that have diseases that could be dying from them. So you put them in the study, you're going to go through it, you know they're not getting the drug, they're not going to get any better. You might treat them differently than somebody over here that's getting the drug and really trying to get better. You might give them more care, which is going to change the results. So the double-blind studies kind of eliminate that possibility. Okay? There are such things as single-blind studies, which means the participants don't know, but the other people on the researchers do know who they are. So that's not used as often. Double-blind is the standard nowadays. All right. Let's see. I hit pretty much all the main points on that one. Oh, we can talk about all right, we talked a lot. Most of the stuff's dealing with the controlled experiments so far. But let's look at a little bit more, and I don't have anything up here, so let's look a little more on the observational study side. So observational studies are your surveys, collecting data, things like that. What's something that could come into play if you're just collecting a bunch of data?
Outliers?
You could have some outliers. What else can come into play? Huh? Lying. Okay, so far that's all on the participant side. What can come on the researcher side? Yeah.
Miscalculation.
Yeah. You're giving them too much credit. Bias. If I'm doing a study, I kind of know what I want the outcome to be. Like most people that are going in and doing something, they want a certain outcome. Like if I'm creating this new drug, I want it to work. Okay, that's the goal. I want this to work. If I'm doing a research study, let's say like comparing television to grades, okay, or social media usage to grades, because that's a little more common now than television. I might go into that going, of course, social media affects grades. The more people are on that, the less their grades are going to be. Like, this is what I believe. I'm now going to go out and do research to try to prove my belief. I've walked into that with a bias. By going into it with a bias, that impacts how I'm going to create the questions, that might impact how I'm looking at the data, that might impact how some data that I might eliminate because I think it's an outlier where it might not be statistically an outlier. That has a lot of impact on it. And just asking questions in a certain way can get you certain answers. Okay. If I gave you a list of names and I told you to randomly pick one, if there was 5 names on the board and I told you to randomly pick one, which name do you think would be chosen the most often? First, second, third, fourth, or fifth? Or the middle one? Okay. It depends on if it's all listed in front of you and you're choosing from that list. It's first, middle, or last will be the ones that'll show up the most. Just because that's there. If I was staying a list out, speaking it to you, it's either the first one or the last one. Because it's either the first one because you stopped listening, and that's just the one you're going to pick and tell me, or it's the last one because you weren't paying attention, you caught the last one before I ended the question. Okay? So, if I am going to give you a list of presidential candidates, if you go into a ballot box, they're listed in a very specific manner. The party that's in power is always listed first. So if you're looking at that list, the first one is where you typically start looking. That one's voted on more often than the last one because it's the first thing they say. Okay. If I'm reading a list of names to you, how they list those names in that order will matter. So a true survey should randomize those names so that the first name is not always the name that's the same name that's given. And the last name is not always the same name that's given, because that will then impact those questions. We saw it, the question like the binge drinking and stuff like that, depending on when they ask those questions, would have a major impact on the answer to it. So that's where your bias can come into play when you're writing your questions that you're going to ask. So if you're doing this as truly a scientific matter and a scientific research, somebody else should also have to redo it and read those questions and write questions and something else to make those changes. And you might want 4 or 5 different versions of the same question asked in your survey. So this way, and you would ask them at different times in a little different ways. So when you're going through, the person might think you're asking the same question, but you're asking it in a slightly different way to see if you get the exact same response. That can help you eliminate some of those biases. So it's, even if you're just looking at collecting, like just having data, forget a survey, you're just going out and looking for data. Depending on how you're going to pick that data can actually make some differences in your biases. So these are all the things that like you really have to think about if you're going to do a study, but also for a normal person, for when you're looking at somebody else's data. how did they do this? Why did they do this? What were their biases going into the place? Okay. We hear a lot about now, we have the mass media, like the liberal left media and then the right media. Fox News is always this, CNN's always like those type of things. Like those do exist. Everybody has a bias. Even if you don't think you have a bias, you have a bias. Okay. It just might not manifest itself as well, but when you start looking at stuff, you're going to start to see that bias, and somebody else might see it that you don't notice it. So that's important. All right. On to the next thing. All right. Now we're going to start looking at some different types of data. We have two main types of data. We have discrete data that will have gaps in it. So 1, 2, 3, 4, that's discrete, not continuous. Why? Nope. But they are numbers, and numbers can be variables. Mostly variables are letters, but we can have the other way too. Yeah. So, but why is 1, 2, 3, 4 discrete and not continuous? Yes. Yes. There's numbers between 1 and 2. We don't always think about that, but there are. Like if I gave you the discrete and I gave you the example red, yellow, blue, green, orange, that's obvious. Those are discrete data. There's nothing between, like, yes, we can have different colors between them, but even that would still be discrete. All right. But when we start thinking about numbers, we automatically go to continuous, where it's not necessarily true. Or like A, B, C, D, that's obviously discrete. There's nothing between A and B. Okay. Continuous means any value in between those could work. Okay. So if I was going to ask, so body temperature, discrete or continuous? I've heard both. All right, who wants to make the case for continuous? Go ahead. Go ahead. Yeah, you can. Why is it continuous? Okay, somebody else then. Okay, that would make something discrete or continuous though? That can change? Yeah. Yes.
Your full body temperature like ranges from high 96 point something to 98 or 99. So those are the sets we're taking for average.
Mhm.
So any number you're getting, you can
Yes, you can get any of them. Like, so I think, what did I hear today? Anything below 95 is considered hypothermic. I was watching Bering Sea Gold today, and like this person jumped in the water and their body temperature was 90 degrees. But so, and you can have, I had a fever at one point, actually, when the swine flu came out, that was 106. Not good. So, but any temperature between those could work, right? It just depends on how precise your thermometer is. You could have a temperature at 98.32 degrees. Your thermometer might not show up, but you could. Okay. If your temperature could only be 98, 99, 100, then it'd be discrete. But temperatures can be any of those. Okay. I think, yes.
Is there any like data set besides numbers that would be continuous?
I would say no, but as with everything with math, there's always a possibility. I could see somebody making the argument that colors could be continuous. just because you can have a variety of values between the colors that they might not have a name, but they are technically different colors. So like the screens can display somewhere around 16 million colors. It's 256 to the third power. They all don't have names, but they exist. So I could see somebody making the argument that colors could be continuous. I would say no. Basically, numbers are the only ones that you would really have as being continuous. The bigger question, though, is not necessarily that the values are, it's what's the data do? Because you can have situations where numerical values are not continuous. If you're going to say how many children you have in the family, that is a position where or how many people are in your family. The values are going to be whole numbers. They are not continuous. You can't have 2.5 children. It just doesn't work. So that would be discrete data where your temperature would be continuous. Does that make sense? Okay. All right. So up to now, pretty much everything I think I've talked about, you probably have heard at one point in time. I'm going to bet the next 6 things I'm going to talk about you probably haven't heard of before. Some of you might have, but you probably haven't. We have 2 different types. So we have our discrete and our continuous data. But we also have the other ways we look at data is known as qualitative and quantitative. Yes, they're both cues. Yes, they're going to be annoying because they both sound similar. It was like last night watching Wheel of Time, and I said Sean Chan and Sonaran, and she was like, they both start with S's. Which one's which? Qualitative and quantitative. So qualitative data is either nominal or ordinal. Okay. A nominal data are ones that basically anything that can represented as a variable. So that have not necessarily any order. So if I asked for your hair color, that would be nominal. Okay. If I asked for your shoe size, that would be ordinal. What's the difference between those two? Okay, so if you look at the definitions, what's the difference between nominal and ordinal? Yeah.
Right, but where it says that they have some associated order to 7, 7.5,
Right.
8, 9.
That's the difference.
Or your color, I have brown, he has brown, but my
Right.
brown is a little lighter than his.
Right, there's no order to it.
There's no order to it.
Correct. Okay, that's the difference between those two things. Okay, so nominal does not necessarily can't have order. Right, it's just literally a list of information. Ordinal has some kind of order to it. So here's an interesting one. Your social security number. Is it nominal or ordinal?
I think it's ordinal because when you get issued, the first 3 digits mean your region, the second 2 means something else, right?
Yep.
And the last 4, like it's by your, like where you live.
Yes. The first 5 digits have a meaning. The last 4 don't. The last 4 are completely random. Yes. Which means it's nominal, not ordinal, because there is no order to it. Okay. It's one of those things and that's one of those ones that is very tricky because it's a number. He's like, okay, well, there's got to be some order to it. Same thing with phone numbers. Phone numbers are nominal. We can't put them in order. It wouldn't there's no reason to put them in order, even though it's a number. Okay. Putting your phone numbers in order doesn't mean anything. And that's the big difference. Does putting them in order mean something? So like if I was to set you up by height, that would mean something if I put that in order. Or your shoe size, I could put that in order and that would have some meaning. But ordering your phone number or your social security number doesn't mean it. Oh yeah, and the number pi, all your social security numbers are in it. In pi. And right next to your social security number is your birthday and your phone number. All in that order. Anyone want to guess why?
Because the pi is a number that extends forever. And because it extends forever, there will be a point where that combination of numbers happens.
Exactly. And it never repeats itself. So it's always randomized, basically. So there's somewhere in pi that happens. I can't tell you where, but it happens. All right. So we've talked about qualitative data. The other one is quantitative data. Quantitative data, when we look at calculations on it, they mean something. Okay? So we can look at the difference between values, and that has some meaning. We can look at the ratio of that data, and that has some meaning. So we have interval data and ratio data. So interval, I can subtract. So if we go back to, and honestly, it really isn't that big of a difference, but it can. Like shoe size. Like I can say your shoe size is 3 shoe sizes bigger than somebody else's. Is that data useful? No. But I could say that. Okay. There is some meaning to that. Or height is a great one. Like I can say you're 3 inches taller than somebody else. That has meaning. So that would be an interval data. So your height data would be interval. Ratio has 2 main pieces that are important. One, it has to have a 0 value. That means something. Okay. So interval doesn't necessarily have to have a 0. All right, you're never going to be 0 feet tall or 0 inches tall. Okay. There probably is a shoe size of 0, so I can't say that. And just because women's clothing is completely crazy, there's a 0 and a double 0. So, which still, I don't care how many times anybody's tried to explain this to me, I will never understand women's clothing sizes. It makes 0 sense.
I don't think women understand.
No.
women's clothing sizes.
No, like it doesn't make any sense. It's like guys' sizes are easy. Pairs of pants, that's literally the inches of the waist. Like that's it. I buy a 42 anywhere, they're all the exact same. The only difference would be they might be a little stretchier than some of the other ones, but it's like they're all the exact same. It's 42 inches. But yeah. So that would necessarily be your intervals because, and actually even men's pant size would be intervals because there's order to it. I can subtract them. That would make sense. Okay. Your ratio data is things that you can divide. So can I find the average of it? If I can find average, that's a division. Okay. Can I say something is twice as much as something else? That's a division. That would be ratio. All right. So we can start to look at your qualitative data. We can't really do any calculations on. Your quantitative data, you can. Okay. Our qualitative data we can put in order, but that'd be about it. Our quantitative data, we can start looking for means. We can start looking for modes. We can start looking for medians. We can start doing standard deviation on it, those type of things. We can do calculations on it. Both data is important. Right? We use both sets of data. Just we can do more with the quantitative data because it's numerical. Math likes numbers. So, okay. And when we go into chapter 3 and we start looking at graphing them, different types of graphs will lend themselves to different types of data. So when we're looking at our bar graphs, we can look at qualitative data because we can count. And that's fine. We can count and make our bar graphs for it. But if we're looking at maybe histograms and stuff like that, we need more quantitative data. And there is a difference between a bar graph and a histogram. And you're going to learn that next week. All right. Let's start looking at some questions. So this question asks something that's very important. Are the variables well defined or not? What do you think they mean by that? Yes.
Well, I mean, by well defined, I think they mean like a number that we can like construct within math. Like I see there's beauty down there, and I don't think you can like really define beauty because it's kind of a social construct, and I think like observable in math.
Okay. Yes.
It's well defined, subjective.
Yes. That's the key piece there. If it's well defined, everybody will agree on what it is or not. So it's objective. If it's not, it's subjective and it's not very well defined. Which leads to what you said. There, beauty is not an objective standard. It's subjective. Although, as funny as it's going to say, there actually is a mathematical formula for beauty. It's all about symmetry. It actually has nothing to do, like you can, like socially, you can look like the ugliest person in the world because your eyes are too big or whatever else. But if your body is in perfect symmetry, that is the mathematical definition of beauty. Because our minds look for symmetry. If you look in nature, things that are more symmetrical are considered more beautiful. All right. If you have two flowers and one's more symmetrical than the other one, the one that's more symmetrical is the one that you're going to desire. So, but for the most part, beauty is a social construct. So that would not be well defined. Height, well defined or not? Yes. Yes, we have the standard version and the metric version, but it's still well defined. Hot. That is subjective, as I'm told on a regular basis. Weight. That is objective. Temperature. What are the three temperature scales? Very good. Went over to Ireland this summer. I had to explain to them how to use Celsius. It was fun. We already talked about beauty. So temperature and hot are very related, right? Temperature is well defined, hot is not. Same thing with cold. It's like you can be cold at 72 in the winter, or actually you can be cold at 72 in the summer and hot at 72 in the winter. It's like it's the same thing. So that's why I tell my students never to wear their jackets into class, because when you walk outside, your jacket's not doing anything for you anymore, because the temperature changes, what makes you either hot or cold. So that's why 72 in the winter is hot, and you're going to be wearing probably as little clothing as you can because you're going to be sweating. But in the summer, 72 is gorgeous. It's like we're even a little cool to some people. So you probably wouldn't go to the beach at 72. You would in December. All right, a couple more. Yeah, let's do this one. So we have 4 levels of measurement. I didn't actually call it levels of measurement, although I probably should have. The levels of measurement are nominal, ordinal, interval, and ratio. Okay, so those are the levels of measurement. So when they say levels of measurement, they don't mean like what's the lowest and the highest. They actually mean one of those 4. It's a statistic thing. All right, so golf score in relation to par. So let's start with the easy one. Is it qualitative or quantitative? quantitative. Okay, so we can do some calculations on it. Now, is it interval or ratio? Okay, why is it interval and not ratio? Okay, so there's no real division doesn't mean anything, right? And that's really the question. Does division mean anything? Because that's what a ratio is. So if I divided your 1 under par to somebody else's 3 over, it wouldn't make any sense. But I can subtract them, and that would make a difference. So that is interval. SAT score. Qualitative or quantitative? Quantitative, okay? Interval or ratio? Okay. So we can do our average, we can do our percentiles. So that would be ratio. A rating of 1 to 5 of quality of service in a restaurant. So 1 to 5 stars. Qualitative or quantitative? Why is it qualitative and not quantitative? Okay. Why is it quantitative and not qualitative? For the people who said quantitative. Well, no zeros just means it wouldn't be a ratio because the interval doesn't necessarily have to have zeros. This one would be qualitative because subtracting them doesn't really mean anything. Okay, like okay, minus 3 stars or 2 stars, like that doesn't really mean much. Like an addition of 2 stars wouldn't really make it's a qualitative measure. Okay. You can think of a little bit more of subjectivity in that respect, but remember, you still want an objective measure, so it wouldn't be totally subjective. But the calculations wouldn't make much sense in this respect. All right, make and model of a vehicle. That's qualitative. That one's pretty easy. The number of students with a business major. Okay, is it interval or ratio? Does it have a meaningful zero? Could you have no students with a business major? Yeah, you could. So, and you could divide those and figure out like different things in colleges and stuff like that. So there would be some calculations and stuff there. So you can start to see how some of these actually are quite difficult to decide which one's which. Yes.
Do you know that more depth with what a meaningful zero is? I know you did that earlier.
So a meaningful zero just means that zero could exist. So like we were talking about like height. You can't have a zero for height. That wouldn't make much sense. You can have, well, actually, you can't have a zero for the SAT scores. The minimum would be 200, but you could have a zero for a grade, for example. So that zero means something. It's not just a zero that's zero. It's a zero that actually means something. Even though the relation to par was not ratio because dividing it doesn't make sense, there is a zero. That there actually is a meaningful zero in that situation. So you could have certain situations where you could divide things where a zero doesn't make any sense in that respect. Actually, like IQ. You won't have a zero IQ, but you can do division in those calculations around with IQ scores. Same thing with height. You can start doing division stuff, but the zero wouldn't mean anything. So even at that point, it still would be considered an interval because it doesn't have a zero that means something. So no problem. In all honesty, most of these things, once you start to actually work with it, you're going to know what data you can do things with and what things you can't do it with. So it's like we were talking about at the beginning, we were drawing like the dot plots and we want to connect the lines. Like, does the line mean something? No, it doesn't mean don't put it. That type of thing. So when we start getting to actually doing the calculations, you'll start to understand it's like, okay, this set of data I can do that with. This makes no sense to do it with. So. All right. One more. All right. So the results of a study investigating the nutritional status of mid-19th century Americans was reported. So the data is based on the physical examination lists for West Point applicants from 1843 to 1894. Some of the information obtained from each cadet was his height, weight, state from which the cadet was appointed from, the occupation of the father, the incomes of the parents, and the type of home residence, city, town, or rural of the cadet. Okay. So, what are the different variables that they measured on the cadets? So, okay, let me actually ask this a different way because I'm going to have to go back. We're going to have to do this multiple times. I don't want to do that. Give me one variable that was measured on the cadet. Yes. Height. Okay. Is that a quantitative variable or a qualitative variable? Quantitative. So they can do those calculations. What's the type of measurement that one is? That's an interval. Because there's no meaningful zero. All right. Next variable. Pick me another variable. All right. So we're just going to go down the list now. All right. So wait. Qualitative or quantitative? It's quantitative. Okay. Level of measurement. Huh? Interval. Because again, there's no. Huh? Okay. Yeah. There's no zero weight doesn't mean anything. All right. Then we'll just keep going down the list. State from which the cadet was appointed from. Qualitative or quantitative? Qualitative. What kind of measurement? Nominal or ordinal? We haven't done a lot of these. Nominal. Why? Right. But so the only difference between nominal and ordinal is what? The list, the actual order, right? Can I order the states? No. I could, but it doesn't make much difference. Like, there's no real reason to. Ordering them alphabetically or how they came into the union, like, there's a bunch of different ways. None of them really mean anything. Occupation of the father. Qualitative, nominal or ordinal? Nominal. There's no real order for it. Income of the parents. Quantitative. So is it interval or ratio? Ratio, because zero can mean something. Type of home residence, city, town, or rural? Qualitative. Now, is it nominal or ordinal? This one you can order, and it actually would make some sense. You'd order them together. So you'd group all the city together, all the towns together, all the rurals together. So there is some rationale to be putting those things together. Okay, what's wrong with this study? Well, they really were trying to figure out, what was it, the nutritional status of mid-19th century Americans. So the number one way to figure out like how people's nutrition is to look at like their height, their weight, those type of physical characteristics. Yes.
I'm assuming West Point, based on where it says cadet, West Point is a military base, I'm assuming. Therefore, it would only be young men.
You don't know what West Point is? West Point is one of the military colleges, yes.
My dad's Navy, so like I only know Navy stuff. I mean, like,
So where's the Navy one?
I don't know. I don't know.
The Navy is Annapolis. The Navy is Annapolis. And the Coast Guard is London. And anybody know where Air Force is? Colorado Springs. So yes, those are the four military institutions. So yes, so okay, so West Point is Army. So yes, they'd only be looking at young men. That is very true. What are some of the other problems with the study? How many people in here do you think would qualify for West Point? If we look at it today, okay, you have to be, if you were looking at today, how many of you would qualify for West Point?
For the Marine Corps, there's less than the population.
There might be a few of you in here that could. Okay, but not most of you. It's extremely hard to get into West Point, and one of the things you need to get into West Point is you need a congressional appointment. So, how many of you know a congressman or a senator personally that could get a letter from them? Okay, as I'm saying, it's not that easy to get into it. So now, what else is wrong with this study? What type of person would qualify for West Point in the mid 1800s? Yes. Somebody that's already physically fit. I already heard what was the other one I heard? Rich people, people who had money. Okay. So if you're wealthy and connected and have money, what's your nutritional status going to be? Probably pretty good compared to a poor farmer in the middle of West Virginia. They're probably not getting the same nutrition as you are. So their study of nutrition is going to be quite skewed. Okay, so yeah. Also very interesting things of the it's funny how they worded this, because this is kind of funny. It was, they wanted to know the occupation of the father, because in the mid 1800s the woman didn't work. But then they asked the income of the parents, and I'm really thinking that was somebody who's typing this out and didn't like think it through, because the father was the only one bringing in money at that point. Because even like there was some women that worked as nurses and as like teachers and stuff like that. However, typically they didn't have a family. They were single. When you got married, you didn't work anymore. You stayed home. So yeah, there's a lot of problems with this study. This would be a great case of bias in the researcher. So, all right. Okay. Yeah, we won't do that one. All right. Any other questions? I did remember to record. And I turned on closed captioning. Now I'm going to stop recording. I will put